formation of a new substance, and the initial substances which are involved are known as reactants, and the substance which is produced is known as product. So when two or more substances combine together, they are known as reactants, and when they form a substance, we call them products. So this is chemical reaction: iron, setting of milk into curd, and digestion of food, and respiration. So these are the examples of a chemical reaction. Now here, when any chemical reaction takes place, there is a transformation of two or more substances, and which results in the formation of a product. And whatever product is formed, it has entirely different properties from those of the reactants. And if you remember, in previous class, I have already explained about physical changes and chemical changes also. So there is a difference between physical and chemical changes. So in this chapter, we'll study about those chemical reaction and the changes takes place. In physical changes, if you remember, I told you in previous class, no new substance is produced. Only there is a change in the state, and there is a change in color, size of the object, of the substance. But if a chemical reaction takes place, the properties are entirely changed. For example, when we prepare curd from a milk, the property of the curd is entirely different from that of the milk. And another example is when rusting takes place in an iron. So what happens when rusting takes place? The properties of the rust are entirely different from those of iron and oxygen, which were involved in this chemical reaction. In previous class, I have already explained about the characteristics of chemical reaction. Students, when any chemical reaction takes place, then what happens? There is a rearrangement of atoms takes place, and the substances which are involved, we call them reactants, and the new substances produced are known as products. This example also I have discussed with you. When magnesium ribbon burns in an air, it results in the formation of magnesium oxide. Here, magnesium oxide is a product, and magnesium and oxygen are the reactants, as you can see here. And the property of this magnesium oxide is entirely different from that of the reactant, like magnesium and oxygen. Now, what type of question can come on the basis of this? This is very frequently asked question. Why is magnesium ribbon cleaned before burning? As I told you in previous class also, magnesium is a very reactive metal. It can readily react with oxygen, and which results in the formation of magnesium oxide. So, first of all, we remove that layer from the ribbon so that it can prevent or slow down the burning of magnesium ribbon. And in addition to it, some impurities are also present. So if we clean this magnesium ribbon, we are removing those impurities also, so that it can burn very easily. So that's the reason why is magnesium ribbon cleaned before burning. First is to remove the layer of magnesium oxide. Second, to remove the unwanted impurities. Now, what are the characteristics of a chemical reaction? When any chemical reaction takes place, there are some changes we observe in that. First is evolution of gas. A gas can evolve. That gas can be anything, sulfur dioxide, hydrogen, any gas can be evolved. And this arrow here shows the evolution of the gas. And in this example, where we have taken zinc and sulfuric acid, when they both react with each other, it results in the formation of zinc sulfate and hydrogen gases evolve. Second characteristic is change in color. When two substances combine together, it results in the formation of a new substance and there is a change in color. See, when any chemical reaction takes place, it's not necessary that all these characteristics are there. It can be one, two, anything. So, we observe these characteristics in a chemical reaction. For example, when citric acid reacts with potassium permanganate, so the color of the potassium permanganate, which is purple, it becomes colorless. Another example of such kind of this change in color is when sulfur dioxide gas reacts with potassium dichromate solution, its color changes from orange to green. Another characteristic is change in state of substance. And if you remember, I told you in previous class also, when we burn a candle, it results in the evolution of carbon dioxide gas. And when we burn a candle, the wax starts melting. It changes into liquid form. And these are the examples of change in state of a substance. Change in temperature. When two substances react together, then either the heat is evolved or heat is absorbed. So it results in the change in temperature of that chemical reaction. And the example of such kind is when a reaction takes place between quicklime water and which results in the formation of slaked lime. In this case, there is a rise in temperature. Another example is when zinc granules. As you can see here, when zinc granules reacts with dilute sulfuric acid, it also results in the change in temperature, which means there is a rise in temperature. The temperature increases. And another characteristic is formation of precipitate. Precipitate means some sort of a solid substance, but which is powdery. When you touch it, it's like a powder, soft powder. So the best example is when barium chloride, BaCl2 is barium chloride. When it reacts with sulfuric acid, it results in the formation of barium sulfate and hydrochloric acid. And this barium sulfate is present in the PPT. PPT here means the precipitate. It represents the precipitate state. So these are the characteristics of a chemical reactions. Now what type of question can come? Write down the characteristics of chemical reaction. So in this question, you have to write all the characteristics, which are evolution of gas, formation of precipitate, change in color, change in state, change in temperature. Or sometimes any particular this characteristics can be asked in exam with the help of example. For example, in an exam they can ask write down a reaction in which there is a formation of precipitate. So in this kind of question, you have to write this fifth point only this fifth one. Or if the question demands, write the reaction or give an example in which there is a change in temperature. So out of these two, you can give any one example. So it can become in any form. Now when we are representing a chemical reaction, we always represent a chemical reaction by its symbols. Whatever substances are involved into it, we always represent it by their symbols. Here I have taken one example, A plus B, C plus D. These are not the symbol, this is just an example. That instead of writing the complete name, we represent a chemical equation with the help of these symbols only. As you can see here, this Na. Na is the symbol of sodium and Cl is the symbol of chlorine. So when sodium and chlorine reacts together, here remember these are reactants. It results in the formation of NaCl, which is a sodium chloride salt. This is sodium chloride salt. This is a salt which we consume on a daily basis, and it is represented by NaCl. Now, another example of a chemical reaction is hydrogen and oxygen. See, here, when hydrogen and oxygen, they both react with each other, it results in the formation of water. And when water is formed, the properties of this water is entirely different from that of hydrogen and oxygen. So in this, we can see hydrogen represented by the symbol H and oxygen is represented by the symbol O. And when they both react together, they form water. The formula of water is H2. So these symbols represent a complete reaction. Now there are two types of reactions. One is balanced one and the another one is unbalanced one. Balanced reaction is that reaction in which the reactants and products, they both are equal in numbers. An unbalanced chemical reaction or equation is that kind of equation in which the number of reactants and the number of products are unequal, or they are not equal in number. If we see here in this example, as you can see, here H is 2, here H is 2. Oxygen is 2, but oxygen is 1. So this is not a balanced one. So how can we balance a chemical equation? See, balanced equation can be that equation in which, as I told you, the number of reactants are equal to the number of products. If you see here, zinc, here is 1, here is also 1. Hydrogen 2, here hydrogen is 2. Sulfate is 4, here sulfate is 4. So in this manner, the reactants are equal to products. So this kind of reaction is known as balanced chemical equation. And why there is a need of a balanced chemical equation? Because according to law of conservation of mass, that mass can neither be created nor be destroyed. So it means whatever reactants we are taking, it results in the formation of products. So balanced chemical equation always obey law of conservation of mass. It states that total mass of elements present in reactants equal to the total mass of elements present in products. As you can see here, the total number of reactants are equal to the total number of products. Another equation is this one. If you'll see this previous equation, this one here, this is unbalanced chemical equation. The total mass of reactants are not equal to the total mass of the products. So this is not a balanced one. This is unbalanced equation. But if we talk about this reaction, it is balanced. As you can see here 2 molecules of hydrogen, here also 2 oxygen, here also. If this represents, it means here also 2 molecules of oxygen are present in this. So total number of reactants equal to total number of products. So they have equal masses. how to balance a chemical equation. I'll just take one example for you. As I told you, if the number of atoms in each element is not equal in reactants and products, so we call that kind of equation unbalanced chemical equation. If you see this example, here we have iron, hydrogen and oxygen. So these three elements are present. Children, one more thing I need to tell you. When any chemical reaction takes place, so it results in the formation of product, same elements are present in the products as well. Although it results in the formation of new substance, the compound can form, but the composition of the elements is same. So if iron is here, iron also be here in the product, and if oxygen is here, oxygen is here also, and if hydrogen is here, so hydrogen we see in product side also. Now if you see this equation, here the number of atoms of each element are not equal. For example, this is, if you see left hand side and the right hand side, so when see only one iron atom is present, here we have 3. In this, 2 hydrogen are present, here also 2 hydrogen are present. Here oxygen is 1, here oxygen is 4. But balanced chemical equation is that in which each and every element is balanced. In this, each and every element is not balanced. Only hydrogen is balanced here. So it does not come under the balanced chemical equation. It is not obeying the law of conservation of mass, which states that the total mass of reactant is equal to total mass of products. So this is unbalanced one. And in this diagram, if you see here, this is silver oxide. Here, Ag is a symbol of silver and this is O is a symbol of oxygen. Here Ag is 2, here is 1 only. Here oxygen is 1, here 2. So this is unbalanced equation. And how to balance this? If I write 2 here, it means 2 molecules of the silver. So here we multiply these two numbers. 2 2s are 4. So here we'll write 4 also. And here now 2 oxygen, 2 oxygen. Now this is balanced equation. Now how to balance a chemical equation? There is a method which we call it hit and trial method. Hit and trial method. Hit and trial method we use for balancing a chemical equation. How we can use this hit and trial method? Let's see here. Here is one equation just in front of you in which iron, hydrogen and oxygen, these 3 elements are involved in reactants, and in products also we see iron, oxygen and hydrogen. See, when we balance a chemical equation, first step is to write the number of atoms of elements. First we need to name of the atom, name of the element present in a chemical equation. So here we have iron, which is represented by Fe, and hydrogen, which is represented by H, and oxygen, which is represented by O. So first step is to write the name of the elements involved in a chemical equation. And best method to write this balanced chemical equation is whatever the substance is present in maximum number, you have to write that substance in a table form. Like we have this compound which is present in maximum in number. So it has iron and oxygen. So only hydrogen is left. So we have written all the elements which are involved in a chemical equation. iron, hydrogen and oxygen. Now, second step is write the number of atoms in the reactants and the number of atoms in the product. Here, if you can see, number of atoms in the reactant in iron has 1 and in product it has 3. So, I have written 3 here. Now, come to hydrogen. On reactant side, it is 2. On product side, it is also 2. Now, third is oxygen. On the reactant side, it is 1. And here it is 4. So, if you see this table, you'll get an idea which elements are balanced and which are not. So, if you'll see here, only hydrogen is balanced. And iron and oxygen are not balanced. So, we need to balance these two elements also. Now, next step is, if you want to balance, so this balance the atom which is maximum in number on either side. So, here, first of all, we need to this element which is maximum in number. As I told you, see, here oxygen is maximum in number. So, first we'll choose oxygen for the balancing. So, here it is 4, but here it is 1. So, we'll multiply this 4. I'll write 4 here. If I'm writing 4 here, it means 4 molecules. So, this 4 is applicable to both, or hydrogen and oxygen. Fine. Now, in this manner, this oxygen is balanced. But if I am adding 4 here, hydrogen becomes unbalanced. Here it is 2. Now it is 4 2s are 8. So now we need to balance hydrogen. Now how can we balance? I'll write 4 here in front of this hydrogen. Now if you'll see, 4 2s are 8. Here hydrogen is 8. And here also hydrogen is 8. Here oxygen is 4. And here also oxygen is 4. Now third is iron. Now it's a turn for the iron element to get balanced. Here 3 are here. So I'll write 3 here. I'll multiply iron with 3. Now, if you will see here, after writing this, on reactant side, again I am writing in a tabular form. This is elements. Okay. So now again I am writing, after doing all these steps, again I am making one table in which I am writing the elements. Now I'll write the name of the elements again: iron, hydrogen and oxygen. Here if you'll see, on the reactant side, iron 3 in number. Here also 3 in number. Just see this. Just look at this equation only now, which I have just balanced. Now I'll come to hydrogen. We'll see here 4 2s are 8. So on reactant side it's 8. 4 2s are 8. Again it is 8 on the product side. Now oxygen. This 4, as I told you, 4 molecules of oxygen are present in water. In this one, compound of this water. So it means 4 here. Here is also 4. Now if you will see, all the elements are well balanced. As you can see here, 3 3, 8 8, 4 and 4. So all these elements are now balanced. And this is known as balanced chemical equation. And this type of method is known as hit and trial method. So I hope this is clear to everyone. And if you have any doubt, you can write in the chat box so that I can see your doubts and I'll clear your doubts there and then. So this is known as the balanced chemical equation. When we are writing any balanced chemical equation, so after balancing, we get this complete equation. This is known as balanced chemical equation. Now, when we are writing any chemical equation, how can we make that equation more informative? More informative means here, when we are writing any chemical equation, that chemical equation itself clear all the details of the reactants and the products which are present in that chemical equation. Now, if you'll see here, first of all, we need to write the physical state. Physical state means whether the element is present in solid form, liquid form or gaseous form. So, here S shows the solid form, L shows the liquid form and G shows the gaseous form, and if EQ is written, it shows the aqueous form. Aqueous form is that form, the substance which is dissolved in water. Which can dissolve in water is known as aqueous solution. When we dissolve any substance in water, it becomes an aqueous solution. So these are the physical states of a chemical equation. G represents gaseous state, L represents liquid state, and S represents solid state, and AQ, aqueous solution, represents this aqueous state. Apart from this, if an arrow shows in a chemical equation, it shows the direction of a chemical reaction in which the reaction proceeds. So here I am writing reactant, here I am writing product. It means reactants are converting into product. So this arrow sign indicates the direction of a chemical reaction. Next is, if we are writing, and this chemical equation also shows on the conditions. Under what conditions that chemical reaction takes place. Here conditions means whether it takes place at 300 degrees Celsius or 250 degrees Celsius. So these are, or under what atmospheric pressure. So these are the conditions which tells us whether the condition takes place in which condition. Apart from this, whether we are using any catalyst in a chemical equation. Sometimes, see, when we are writing any chemical equation, so we'll write the name of any catalyst here, any substance. So that, and generally we write conditions on the top of the arrow. Here we write temperature, pressure, catalyst. So these are the conditions, and we always write conditions on the top of the arrow. Then, so here one word is here, catalyst. Catalyst is that substance which helps in increasing the speed of a reaction. It does not involve in the reaction. It only increases the speed. So the function of catalyst here can be any substance. Its purpose is to speed up the reaction only. So conditions we write always on the top of the arrow or below the arrow. Then apart from this, if we are providing heat, so that is represented by this triangle. Okay, so, and if this, for example, I'll give one more example here. Sometimes you people have observed that this arrow shows here. This arrow shows the evolution. It means some gases are evolved. Or if it is written like this, plus heat, it means heat is released. So, and if minus heat, it means heat is absorbed. And if heat is evolved, it is exothermic reaction. And if heat is absorbed, it is endothermic reaction. So these are the informations which we always provide in a chemical equation. Whenever we write any chemical equation, we write all these conditions. And after writing all these conditions, we'll get an idea under what conditions that particular reaction took place, or what are the reactants involved, what products are obtained, and we represent elements by their symbols. And in which state those elements are present, whether they are present in solid state, whether they are present in liquid state, gaseous state, or in aqueous state. And it also tells us number of atoms and molecules present in a chemical equation or reaction, number of molecules. One more thing I would like to tell you, when we are writing any chemical equation, we cannot change the subscript. Subscript here means this one. This tells the number of atoms and this tells the number of molecules. So we cannot change this subscripts. We can change these molecules only. So a chemical equation tells the number of the kind of the elements present in a chemical equation, which are represented by symbols, under what conditions that chemical reaction took place, which catalyst was used in that equation or reaction, whether the heat is evolved or absorbed, whether the gas is evolved or not, in which state that those elements are present, and apart from this, number of atoms and molecules present in a chemical equation. So this is all about a chemical reaction information. Now, here we have different type of chemical reactions. There are different type of chemical reactions: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, neutralization reaction, exothermic and endothermic reactions, oxidation and reduction reaction. So we have different type of chemical reaction, and in all these reactions we always follow these rules. Whenever we are writing any chemical equation, we always write down this information, which clarify the about the reaction. Now first is combination reaction. As the name itself says, combination, it means combining. So here the reactants, two or more reactants combine together to form one product. And this type of reaction is known as combination reaction. As you can see here, A and B, when they combine together, they form AB. It means these are the reactants and they form a single product. So when two or more reactants combine together, it results in the formation of a product. Example of such kind of combination reactions are, this example I have already discussed with you. When magnesium reacts with oxygen, it results in the formation of magnesium oxide. So here these two reactants are combined together, which results in the formation of this product. Another example of such kind of combination reaction is like carbon, when comes in contact with oxygen, it results in the formation of carbon dioxide. If you see here, these two are balanced chemical equation. How can we say that this is the balanced chemical equation? If you'll see, here magnesium is 1, here magnesium is 1, no. So we need to balance it. Here oxygen is 2, but here oxygen is 2. Now it becomes a balanced chemical equation. So how can we balance? In this way. 2MgO. And as you can see here, this S. S means it exists in solid form. This shows the state of magnesium. It exists in gaseous form. And it exists in solid form. Now this chemical, this arrow shows that reaction proceeds in this direction. Now comes to the second one. Now let's check this second reaction also, whether it is balanced or not. First I write carbon and oxygen on the left hand side and right hand side. Carbon and oxygen. Carbon here is 1. Here is also 1. Oxygen 2. Oxygen is 2. It means it's a balanced chemical equation. So in this manner, we always balance a chemical equation. So this is how we balance the chemical equation, and this is about a combination reaction. So when two or more reactants combine together, it results in the formation of a new product. Now second is decomposition reaction. Decomposition reaction means in which one compound decomposes and it results in the formation of two or more compounds. Or we can say that it is just opposite to that of combination reaction. Here, two or more reactants combine together, then they form one product. But in decomposition reaction, one reactant breaks into two or more products. Now, example of such kind of decomposition reaction is like calcium carbonate, which is represented by this symbol CaCO3. When we provide heat, it results in the formation of calcium oxide and carbon dioxide gases evolve. So calcium carbonate is a compound. As you can see here, it breaks into calcium oxide and carbon dioxide. So one calcium carbonate decomposes into two products, calcium oxide and carbon dioxide. Another example of such kind is when ferric hydroxide is heated, it decomposes into ferric oxide and water. Now again, if you'll see here, heat. This shows that some heat is providing heat to this reaction. Here this symbol also represents, we always represent heat by this symbol. And again, arrow shows the direction of the reaction. So this is a kind of a decomposition reaction. Now I think these two kind of reactions are clear to you. Now let's see whether these are balanced or not. If you'll see here, calcium is 1, here is also 1. Then here, oxygen 3, here is oxygen 2 and 1 is 3. Okay, now carbon is 1 and here carbon is 1. So it means this is a balanced chemical equation. Now next is, just look at this reaction. Iron is 2. Iron is 2 here. And this 3 is applicable to both. Hydrogen 3. Hydrogen here is 3 2s are 6. So if I am writing 2 here, it means it is applicable to the entire one. So 2 3s are 6. It means it is 6 here. Oxygen 3. Oxygen 3. So this is also a balanced chemical equation. So in this manner, we can also see whether the equation is completely balanced or not. I hope these two types of reactions are very much clear to you. And in this, we can see how we balance the chemical equation. And if you have any doubt, you can write in the chat box. I'll just see here. Okay. Now the next is thermal decomposition. As the name itself indicates, thermal decomposition. Thermal decomposition means? It means that decomposition of a substance takes place in the presence of a heat. So this kind of decomposition reaction is known as thermal decomposition reaction. Okay, so as you can see here, this is a thermal decomposition reaction.